Between July of 1944 and April of 1945, in the ground held by a single American corps, more than 3/4 of every German gun position that got located was located by microphone. That number sits in a counter-battery intelligence report compiled by 7th Corps Artillery. The first thing worth saying about it is that the men on the receiving end were not confused about what was happening to them, because the German army had studied this exact problem, written down the answer, and built the machine that beat it. The machine was a box of explosive on a bench behind the Volkhov front. Engineer specialists put it together in 1942 in the Army Group North Sector for the 818th Artillery Regiment, which was penned into narrow positions among woods and marshes with a much larger Russian artillery force in front of it. They were solving a technical problem. A gun position gave itself away by sound, so the answer was to hand the enemy a second sound, and that second sound had to be convincing not to a man's ear but to an instrument. So the engineers built a detonation device and tested it against their own sound-ranging checkpoints, adjusting the charge, firing it, reading the trace, adjusting again. They kept at it until the instruments reported that what they had just heard could have come from a 150mm field howitzer or from a 210. They also settled where to put it. A mile in front of the guns it was protecting. Never off to the flanks and never behind. Around the device they hung the rest of a false position. Wood fires burning to leave smoke where a reconnaissance camera would find it. Tree trunks laid out to read as gun barrels. Camouflage renewed often enough to look like camouflage men were still bothering with. The German account of all this, written up after the war for the United States Army, allows that the deception held for a while, then adds a warning against expecting much of it against an alert and well-trained enemy. That was one method out of several. There were roving guns, single pieces pulled out of the emplacement and folded into the fire direction net so the shooting seemed to come from somewhere nobody was. There was the practice of pairing a medium battery with a light howitzer battery and firing them together during registration, because registration was slow and the enemy was listening through all of it. There was the simultaneous fire command sent down the wire to several batteries at once so that no single position could be picked out of the noise, and in position warfare in the east, where guns were thin and shells were rationed, there was the mass concentration on a point target, every gun in range firing one round on one command. 80 batteries, 80 shells, one target, one order. The German record notes the ammunition economy first and the second benefit after it, which was that no listening post could untangle that many simultaneous reports into separate positions. None of this was guesswork. It was a worked solution, tested against instruments, written into practice and paid for. German infantry divisions had gone to war in 1939 with observation battalions of their own, each carrying a survey battery, a sound-ranging battery, and a battery for measuring gun flashes. The Wehrmacht was not being outthought here. It was being outspent. In the spring of 1943, the German army added the piece everybody remembers: a propellant that fired with almost no flash. Guns also began working nearer their maximum ranges, further back, harder to see. Both measures were aimed at the American flash observers, the men lying on hilltops behind instruments with a field of view under 6 degrees, about 600 yards wide at 3 miles. One post calling each flash aloud, so the others could swing onto the same one in time to take a bearing on it. 3 of them had to catch the same flash, or the plot was worthless. Both measures worked. Flash ranging across North Africa and Europe came out roughly 1/10 as successful as sound ranging at finding German guns, and the theater report that says so lists the flashless propellant first among the reasons. The other 9/10 were still there, and they did not care about light. Here is what the other 9/10 physically were. A line of microphones buried in shallow holes several thousand yards behind the front, each hole covered by a metal frame about a yard across and 6 inches high with woven coconut matting stretched over it to keep the wind out. The microphones were hot wire units, a design left over from the previous war and never much improved on because it did not need improving. Wire ran from each of them back to a recording set in a truck. 2,000 yards forward of that line sat manned advance posts, whose one job was to hear a gun before the microphones did and throw the switch, because the recorder could not be left running all day. When the switch went over, the sound of the gun reached each microphone in turn, a fraction of a second apart, and each arrival wrote a mark on a moving strip. Until 1943, that strip was photographic film, developed inside a light-proof box in the back of the truck. After 1943, it was carbon-backed paper marked directly by metal pens, which took the developing step out and the weighting with it. Then a man measured the intervals between the marks and laid them out on a plotting board with fine strings weighted by small lead pieces. One string for each pair of microphones. Where the strings crossed was the gun. There was a further instrument in the truck, a comparator, a purpose-built mechanical calculator that took the recorded sound of the located gun and the recorded sound of the American shells arriving on it, compared the two and produced the correction for the next round. The interval from the first report to a finished location leaving the plotting board ran 3 to 5 minutes for a trained crew. That figure was set by American sound-ranging sections in the previous war and carried into this one with the method largely unchanged. Gunnery took its own time on top of it, but a battery commander who opened fire on a known target in a static sector was, from that moment, on a clock he could neither see nor stop. In Italy, the same equipment reached out and found the railway gun the troops on the Anzio beachhead called the Anzio Express, firing from between 40 and 50 kilometers away. If the machinery running behind a war is more interesting than the shooting, that is most of what this channel spends its time pulling out of the files. Subscribing is the simplest way to keep finding it. The first of these listening lines came ashore in France on June 8, 1944. Lieutenant Colonel Earl Dealey, a coast and geodetic survey officer on loan to the Army, crossed Omaha Beach that morning with the 17th Field Artillery Observation Battalion and set up in an apple orchard about halfway between Formigny and Saint-Laurent-sur-Mer. Dealey's civilian trade was mapping coastlines, and that was the point of him. What these battalions existed to establish to a standard a coastal surveyor would recognize was that a gun in one field and a microphone in another agreed about where they both were. Through August, the battalion worked targets for 5th Corps artillery, while the German 7th Army came apart in the Falaise Gap. Then the front moved, and the whole apparatus stopped being useful. A sound base takes hours to survey in and wire up. During the pursuit across France, the observation battalions kept pace with the advance without trouble and could almost never get set up before it was time to move again. Which is exactly what a generation of American field artillery officers had predicted about them between the wars. In the autumn, the front stopped along the Siegfried Line, and the arithmetic changed back. Under static conditions across Europe from the middle of 1944 to the middle of 1945, sound-ranging stations were putting an average of 750 German batteries a month onto the maps. Which brings the catalog of German answers back into view, and the trouble with it, which was never that anyone had forgotten it. Each item on that list carried a price. The detonation device took men permanently assigned to service it, and a telephone line back to the guns, and whoever timed it had to allow for the speed of sound. The false position ran on fires kept burning, and camouflage kept fresh. Roving guns meant pulling a piece out of a battery already short of pieces. The simultaneous fire command called for a wire net and a headquarters holding several battalions under one hand. The mass concentration wanted 80 batteries inside range of the same target, and shells to spend on them. By the winter of 1944 in the West, the German army had none of that to spare. the same post-war account records that most of its observation battalions carried sound deception equipment at the start of the war, that later only a few of them still had any, and that the few remaining sets were inadequate anyway, because too many different gun types were now in use for one canned bang to imitate them all. One countermeasure stayed free, and it got used constantly, which was to not fire at all. American observers in North Africa and then in Europe reported the same behavior in almost the same words. Hostile artillery fire ceased whenever a light observation aircraft came overhead. The gunners were reading the danger off the thing they could see. The microphones were not up there. They were in the ground, and they worked in fog and at night, and while the German guns were being quiet for the benefit of a spotter plane that had already flown home. On December 14th, B Battery of the 17th Field Artillery Observation Battalion, sitting near Krinkelt, Belgium, reported that most of the enemy shells landing in its area were arriving from the east and the southeast. Early on the 16th, the barrage that opened the Ardennes offensive came down on the battalion itself. B Battery's sound base at Elsenborn had every microphone off the line by 5:03 in the morning. Detachment C's base at Mutzenich stayed up until 5:30 and got 5 gun locations out of it before the shelling took the rest. Every flash observation post in Detachment C had lost communication by 5:30 as well. A battery's base at Lammersdorf held wire to 2 microphones and lost the rest by 6:15. Most of the wire was back up by 8:30. The sound and flash posts went into operation again that morning and stayed in operation for the rest of the battle. The battalion's own history, put together afterwards by men who had been there, points out that the general German preparation is dated in most accounts to 5:30, and that the shelling which took Elsenborn's microphones off the line came before it. From that timing, the compilers drew the obvious conclusion that the 17th had been singled out on purpose ahead of the main attack. No German order naming the sound bases as a counter-target has ever been produced to confirm it, and whoever would have signed such an order did not leave one behind. The next afternoon, one of the battalion's flash posts near Monschau was captured, and a battery near Elsenborn pulled back to Verviers at 9:30 that night, about 2 minutes before its position was overrun. On New Year's Eve, 2 500-pound bombs came down in the headquarters area. Put the 2 ledgers alongside each other, and the shape of it is plain enough. To beat a line of buried microphones, the German army needed spare men, spare wire, spare shells, spare guns to send roving, a headquarters with several battalions under one hand, and a stock of deception sets that had largely stopped being issued. In the West, in the winter of 1944, what it had was 1 barrage, 1 morning, and 3.5 hours.